Hi, in this video I want to talk about how you could generate an EMF using an exercise bike and a magnetic field. Now in an earlier problem I talked about the situation where you have a wire that has free charges, so any conductor, any metal will work. You move it through a magnetic field, and as long as it's moving perpendicular to the direction of the magnetic field, then you can create an EMF across that wire from the magnetic force generating an electrical field. And at the point where they cancel out, you get a motional EMF that's equal to the speed of that conductor times the length of the conductor times the strength of the magnetic field perpendicular to the motion of that conductor. So for a bicycle, bicycles have usually conducting spokes. So what we could imagine doing is taking a conducting spoke and positioning a bike so that there's a magnetic field perpendicular to that spoke. And the easiest magnetic field would be to work with Earth's magnetic field, which has a strength of about 5 times 10 to the minus 5 Tesla. Now, the problem with using something that's rotating rather than something that's traveling in a straight line is that you get a changing speed all along the length of that object. So to find the total EMF, we would need to take a look at the speed from the innermost part of the spoke up to the outermost part of the spoke. So what we could do is we could imagine breaking this up into little tiny segments, and since this is part of the radius of a circle, I'm going to use dr to describe a little tiny bit of distance. So a little tiny piece of EMF, dE, is going to be the speed of that spoke as a function of the radius times the strength of the magnetic field, which I'm setting as a constant, times that thickness dr. Well, the speed of an object in terms of its linear motion related to its rotational motion, the linear speed would be the radius of motion times the rotational speed omega of that object. So if we have a constant rotational speed omega, that tells us that our small bit of EMF would be that constant omega times the constant magnetic field times our radius times a little tiny piece of radius dr. So if we integrate both sides, that tells us that our EMF is going to be omega times the magnetic field times 1/2 r squared evaluated from the limits of integration. Now, in applying resistance to exercise bikes, usually you don't have a uniform magnetic field over the entire length of the wheel. You only have a very small bit where you'd be going from a starting radius to an ending radius. But we're using Earth's magnetic field, so we can use the entire length of the spoke, L. So the EMF per spoke would be 1/2 times the angular velocity omega times the length of the spoke squared times the strength of Earth's magnetic field. Now, let's say that we're dealing with a wheel that has a diameter of 0.8 meters, so the length of each spoke is going to be around 0.4 meters. And if that's the case, 1/2 times the length squared times the magnetic field gives me an EMF per radian per second of 4 times 10 to the negative 6 volts per radian per second. That's not a lot. To put it in context, if you actually wanted to charge a device, you need to be generating about 5 volts using that system. So that means you'd need to be rotating that wheel using Earth's magnetic field at 250,000 radians per second. Given a radius of 0.4 meters, that's the equivalent to traveling at 100,000 meters per second as your forward speed on your bicycle, which really isn't going to work. Now, you could try using a stronger magnetic field. You'd have a shorter distance, and there are generator systems that are based off similar principles, but that's a problem for another time. Thanks for watching.